Hello, we're getting ready to go over some how to evaluate trig functions for exact values. And essentially what that means we're going to look at is if I have an algebraic equation or a trigonometric equation, an equation with a trig function in it, and I don't know the angle, how do I solve to find out what the angle is? All right, so we have a unit circle here. And remember, unit circle means the radius of any triangle, or the line from the center of the circle to the edge of the circle is a unit of 1. No matter what the unit is, it's 1 unit, one of those units. And then you have your horizontal side here, which I have labeled as A, and your vertical side here, which I have labeled as B. And you're going to end up with an end point here, which is A, B. So the length of this horizontal side is A, and the length of this vertical side is B. And remember, we end up with the unit circle with our A value being the cosine of whatever our angle is, and the B value being our sine of whatever our angle is. And tangent is going to be our sine over our cosine. Okay, so one thing you notice is that when you're looking for sine, cosine, and tangent in each of these circles, you're going to be finding different positive or negative numbers depending on which quadrant you're in. So if you're in quadrant 1, because the x value is headed to the right, then x will be positive. And remember, the x value, or a value in this case, is our cosine value. So our cosine will be positive. Our vertical value, in this case b, or generally speaking y, which is our sine value, will also be positive. And tangent is b over a. And since b is positive and a is positive, a positive over a positive makes a positive. So we know here in quadrant 1, all of our cosines, tangents, and sines are all going to be positive. And so each quadrant has its own characteristics of positive or negative values for cosine, sine, and tangent. So in this one, because you're headed to the left from the point of origin, from the 0, 0, you're going to have a negative cosine, but you're still going up vertically. So you're going up on the y-axis. And so that means your sine will be positive. But if you have a positive over a negative in a fractional form, then you know that your answer of that fraction will be negative. So tangent is negative. So in quadrant 2, we have a negative, or cosines are all going to be negative. All of the a values or the x values will be negative. All of the b values, or sine, or y values, so the distance going up, will be positive. Tangent will be negative. And so you can see we have that for quadrant 3, cosine negative, sine negative, tangent positive, cosine negative, sine negative, and tangent positive, because negative over negative. 2 negatives do make a positive in math. In quadrant 4, we have cosine, which is, our horizontal value is going to the right again, so it's now positive. Sine is still going down, so it's negative. And a negative over a positive makes a negative. Okay, so I just want to review that, because one of the things that's important to us and what we're doing is to know where we can find the positive and negative values of each of the things we're looking at. And here it says that the cosine and sine are a and b. And remember, we have the tangent of theta, or any angle, is b over a. So this is what our unit circle generally looks like. Some of the more common angles that we have here are 30, 60, and 45 angles, 90-degree angle, 180, things like that. And I have inside our unit circle the cosine, sine, and tangent. And so thinking about it in terms of triangles, right? Say we have a triangle here. Oh my gracious. Let's see if I can draw that a little bit straighter. We have a triangle right here, a right triangle. So here we have an angle That's theta. It happens to be 30 degrees in degrees, or pi over 6 radians. Okay. Well, our x value, or a value, is going to be this right here, radical 3 over 2. And our y value is 1/2. And remember, on a unit circle, every single radii or radius, from the center to the edge of the circle, is a value of 1. Okay, so it's going to look something like that. And we have an example of that on our next page right there. So when we look at our common, our triangles we should be familiar with, we have a 30, 60, 90, and a 45, 45, 90. Now, if you remember from geometry that you have, anytime you have a 30, 60, 90, you're going to have 1 unit, 2 units, radical 3 units. And 45, 45 triangle is going to have 1 unit, 1 unit, radical 2. Okay, and so when you have 1 as the hypotenuse, that's going to translate into our side A being radical 2 over 2. This is a 45, pi over 4 is 45 degrees, up a radical 2 over 2 and a 1. And it would work the same way with our 30, 60, 90 triangle. So this chart that we have here is an easy reference for you. And this is only referencing things in quadrant 1. Okay, quadrant 1, because it's all positive, as you can see. But some of the things I wanted to point out is that you may see, for example, our sign right here, 1 radical 2, when you're solving, it may not look like that, because remember, you're supposed to rationalize the denominator, which would mean you're going to multiply by 1 that looks like radical 2 over 2 to get that radical out of the denominator, because that's against the rules of math. Okay, so your answer could also look like radical 2 over 2. And you have to, when you see that, remember that, oh, that's that sine of 45 degrees, 1 over radical 2. It's just been rationalized. Okay, so it's the same with any of these that would have a radical on the bottom. This one would be radical 2 over 2 if it had been rationalized as well, depending on if you're looking at cosine or sine. Now, tangent here is one that also you might see rationalized when you're looking at it. So let's find out what that is. We're going to multiply by 1 in the form of radical 3 over radical 3. And so our answer is going to be radical 3 over 3 once it's rationalized. Okay, so you might see those that way as well. Quick, let's look at, I have here, instead of with 1, 2, and radical 3, we have our hypotenuse being of 1 unit, what our vertical side and our horizontal side look like with our radial measurements instead of degree measurements here. So pi over 6 is going to be our 30 degrees. And so you have your, remember, if we drew this on the unit circle here, it would look something like that. And so you would have here your x value, where your cosine is going to go first, and it's going to be radical 3 over 2, comma 1/2. Okay. And you can see that in our unit circle, radical 3 over 2 and 1/2 is this triangle right here. It's just that it doesn't look like a triangle because they didn't, oops, they did not complete the triangle. They just showed you what's called the terminal angle, or the angle in which, if you started from this point right here and rotated around a circle, where it ended. But if you dropped a plumb line down from where that line intersected with the circumference of the circle, drop a plumb line down, you'd have your right triangle. And that's kind of what all of trigonometry is based on, those right triangles right there. So what we're going to keep on our page, what we're going to look at when we complete these problems, is going to be one of the unit circles. And our page right here, our information right here, the 30, 45, and 60 degree things that we're trying to look at. I hope you can see the 60s. It's covered up on my screen with my computer information. I don't know if you're able to see that or not. All right, so let's just look at how would we solve this? Well, we're solving for the unknown, which in this case is x. Sometimes you'd see it as theta instead of x, but either way, it's the same thing. We're solving for the unknown, and the unknown in this case is the value of the angle, and we're going to want it in radians. Most mathematicians or math people prefer radians. It's over degrees. So we're going to want to find our answer in radians, and we can already see it's going to be that way because we have the 2 and radical 3. So what do? Well, we need to get the secant function by itself. So right now the secant function is being multiplied by something and it's being added to something's being added to it. And remember, when you're undoing math, when you're doing algebra, instead of going down, if you're undoing stuff, you're going to go up. So you're going to start by undoing your addition and subtraction first, and then you're going to undo any multiplication and division, and then your exponents, which includes your logs and your trigonometric functions, and then your parentheses. So the first thing we want to look for is any addition and subtraction to undo. So we can undo this plus 2 right here by subtracting 2 from both sides. So we've got a radical 3 secant x equals -2. Now we're going to undo any multiplication and division. So what's happening right here is this is being multiplied. So to undo that, we're going to divide by radical 3. Now this is not a final answer, so there is no need to rationalize this denominator right here. We're just going to leave it the way it is, and that's actually going to help us, because what we need to find out now is, okay, well, what angle do we need to have the answer of a secant be -2/3? Well, we remember that secant is the same thing as 1 over cosine, right? So we don't have our secant and cosecant and cotangent on this list. So let's just go ahead and switch it over to cosine to make it easier. So 1 over cosine x equals -2 over radical 3. Well, cosine now is in the dividend here of this fraction. So to make it be by itself and not being 1 divided by cosine, we're going to use the reciprocal of it. So the reciprocal of 1 over cosine is cosine over 1, or just cosine. And since we took the reciprocal on one side, we also have to take the reciprocal on the other side. So radical 3 over 2. And I don't need to have that negative on the bottom. I can leave the negative on the top. Okay, so the cosine of what angle is going to give me -3 over 2? Okay, now I've got cosine, now I've got 3 over 2. Now it's not negative, okay, but I can see that I have something here, a reference angle. So my reference angle is going to be pi over 6, which is also known as 30 degrees. So know that the cosine of any 30 degrees is going to give me radical 3 over 2. But I also see that my cosine that I'm actually looking for is a negative. And if I remember, my cosine being negative is going to be in quadrant 2 and quadrant 3. So I need to find which of these angles are coterminal angles, reference angles, that match up with the 30-degree reference angle. Okay, so 30 degrees is from your point right here, your line, your starting point. So if you're in quadrant 2, the 30 degrees equivalent would be over here, 5 pi 6. Okay, and same thing with if you were in quadrant 3, would be this one right here. So these are the two ones that have -3 over 2. And you can actually see that in our, it has all the answers here in our points, our coordinate pair here. So -3 over 2, and negative 3 over 2. If you see over here, you've got positive radical 3 over 2 and positive radical 3 over 2 in the place for cosine, because remember, cosine is the first number. But that made it easy for us, knowing that it's going to be the one that's about 30 degrees and knowing already that what we're looking for and which quadrants to look in. So there's two angles we want to consider as being answers for X. Okay, and that brings me to what we have here is our domain. Okay, that means all of our answers for X need to fall between 0 and 2 pi. So X can be greater than or equal to 0, and it has to be less than 2. So it can be anywhere on this unit circle, okay? But we're not going to go and add another 2 pi to it to get a second answer and a third answer and a fourth answer, because it has to stop at one time around the circle. So we're starting at this starting point right here, and we're going one time around the circle. That's what 2 pi means. We've gone one time around the circle, okay? So when we go one time around the circle, there's only two angles that give us that negative 3 over 2 in the spot of cosine, okay? And that's going to be 5 pi over 6 and 7 pi over 6, okay? So those are your two angles. Now, that is a relatively one of the easier types of problems that you're going to see in this kind of work, because your angle is not being changed at all. So you have an angle here that's not got anything directly changing it before the sign or the trigonometric function gets to it, okay? So let's look at this one. It should be the same way. Well, if we're going to undo any addition and subtraction first, so we're going to add one of those sides. 2 sine x equals 1. Now we're going to undo any multiplication and division, divide those sides by 2, and we're going to be left with sine of x is 1/2. So when we look at sine, we find 1/2 right here. So again, our reference angle is going to be pi over 6 or 30 degrees. And the quadrants we want to be in, because this is sine and it's positive, are going to be quadrant 1 and quadrant 3. Okay, so let's look at this. We can see sine for 30 degrees is going to be this angle and this angle. So we're going to have our angle be equal to pi over 6 and 5 pi over 6. And again, that's because we're only going one time around the circle. There is no other place where our sine would equal 1/2, positive 1/2, than those two angles if we start at 0 and take one trip around the unit circle ending at 2 pi. Okay, so that's how we got those two angles. Now this one we can see is going to be a little bit different, because we have here 1/5 times x. So this 1/5, if we think back to PEMDAS, okay, addition and subtraction, multiplication and division, exponents includes logs and trigonometric functions. Okay, so that's where this is, the sign is going to fall. And what's happening to 1/5 times x is happening prior to taking the sign of it. So we should write in some parentheses right there to make sure that you can remember that the 1/5 is stuck to the x, okay, when sign is happening to it. All right, so what sine of 1/5 x equals 0? Well, that's easy. We just need to know the sine of what angle. No, our angle is not x. Our angle is 1/5 times x. The sine of what angle is 0. So that is actually not on our chart here. So it's not going to be 30, 45, or 60. It's got to be something different. But we know that sine is going to be our second number in the ordered pair. So I can see that I have a 0 here and a 0 here. So there are two values that theta can be, or the angle can be. Our angle can either be 0 or it can be pi. Okay, now, but neither of those are our answers because theta, or the angle, is that. But in this case, we're looking for x. Now, again, remember, yours could say sine of 1/5 theta equals 0. You're still only looking for this unknown, okay, which is altered by the 1/5. Okay, so whether or not it says theta, or it says x, or it's a star, who knows what it is? Your unknown is being altered by its coefficient prior to the sign, okay? So we're going to get into how to do that in a minute. But the sine of what angle is 0? The sine of 0 is 0, and the sine of pi is 0, okay? Well, I know both of those. Sine of 0 is 0. I put degrees, I should put R for radians, we're in radians. And the sine of pi radians is 0. Okay, so each of these answers can fit in this place where I have these parentheses. So what we do now is we're going to write what we have in parentheses. 1/5 x equals 0 and 1/5 x equals pi. And we're going to solve for our unknown. In this case, it happens to be x, okay? So we're multiplying by a fraction here. So what we're going to do to undo that is divide by 1/5. Well, when you divide by 1/5, it's the same thing as multiplying by the reciprocal. So we're going to multiply by 5/1, which is the same thing as multiplying by 5. These are going to cancel out, and 0 times 5 is still 0. So x is 0. All right, so we've gotten to an answer there. We're going to consider it in our domain in a moment. Let's first find out what x is equal to over here. We're going to do the same thing, multiply by the inverse, which is just 5. 5/1 is 5. This is going to cancel out, and x is going to equal 5 pi. Okay, so now our domain is between 0, it can be equal to or greater than 0, but it has to be less than 7. So the first one's pretty easy. We have 0 right here. And since we have the ability of it to be equal to it, that is a possible answer. So we can go ahead and include that as one of our answers. But what about 5 pi? How do we figure out if that's within this range or not? Because there's no pi in this range. It doesn't say till 2 pi, which we would know 5 pi is bigger than 2 pi. Well, since it's just a whole number, how we can determine that is we can just estimate pi. Pi is an irrational number that continues on and on forever. Usually you would estimate it to 3.14, but we don't even need to go that far. We can just stick in 3. So we're going to estimate this to be 5 times 3, which is going to be 15. Now, does 15 fit between 0 and 7? It does not. So this is not a possible answer. So our only answer for this is x equals 0. All right. So here we go with almost done. All right, so this is the last example I have before I get into the worksheet that we're going to be working on today. We're going to go back over some of the worksheet problems that we looked at yesterday and just go over those step by step. So, all right, here we have 3 tangent 1/2 x minus radical 3 equals 0. When I do any addition and subtraction first, so I'm going to do plus radical 3 on both sides. Left with 3 tangent 1/2 x equals radical 3. Okay, then remember, I'm trying to get this tangent 1/2 x by itself. And also remember that our 1/2 x is in parentheses. So we can't undo that 1/2 until after we've undone the tangent. So the only other thing we can undo here is going to be the 3 times tangent. And since it's multiplying, we're going to divide by 3 on both sides. So we're going to be left with tangent of 1/2 x equals radical 3 over 3. If we look at our chart over here, that's not on the chart. It's also not any of these options, right? But remember, when you see a radical as the numerator and the same number as the denominator, it's probably one of those answers that has been rationalized in the past. So this is the same thing as 1 over radical 3. And let's just verify that by multiplying it by 1 in the form of radical 3 over radical 3, because that's how you would rationalize 1 over radical 3. And that equals radical 3 over 3, which is what we have. Okay, so it equals 1 over radical 3. Now we can look and say, oh, I see that. So sometimes you'll get these tricky answers and say, oh, there's no solution. It's not on my circle. But you have to remember, sometimes you have to undo the rationalization of the denominator. Okay, so we see that the tangent that is 1 over radical 3 is here. That angle, our reference angle, is going to be pi over 6, or 30 degrees. Okay, and we know it's going to be positive. So tangent being positive happens in quadrant 1 and quadrant 3. Okay, so our angles are going to be pi over 6 and 5 pi over 4. And let's confirm that by looking at these. And remember, our tangent is equal to the sine of theta over the cosine of theta. So let's look at this. Our sine for pi over 6, pi over 6 tangent. Our sine for pi over 6 is going to be 1/2, and this is going to be 3/2, radical 3/2. So when you divide two fractions, that's the same thing. It's keep the first one, switch the division to multiplication, and flip the bottom one to 3 over radical 2. I'm sorry, 2 over radical 3. These are going to cancel out, leaving you with 1 over radical 3, which is what we have over here. So that one checks out. Oops. This one, I circled the wrong one. I circled the angle that's equal to the 45 degrees. So let's look at this again. It should be, no, that's 60 degrees. It should be that one. All right, because we want to go from the horizontal to the terminal angle, and that is 30, 45, and 60. So our 30 is 7 pi over 6. So let's just look at that again. Tangent of 7 pi over 6, just to confirm. And remember, sine goes on top, negative 1/2 over negative radical 3 over 2. Well, those are the same numbers as we had in this one. And we have two negatives. Two negatives make a positive. So it's going to come out with the exact same answer, 1 over radical 3, which is what we're looking for. So we've got the two correct answers here. So we know that tangent of our angles, which is pi over 6 and 7 pi over 6. Either one of those, tangent of pi over 6 is going to be equal to 1/3. Well, I have that written over there, so I don't need to rewrite it. And we need to remember that when we're solving this equation, what we have is we have this 1/2 x. So these are not our answers, okay? This 1/2 x is equal to pi over 6, or 1/2 x is equal to 7 pi over 6. So we do have another step to take. 1/2 x equals pi over 6, and 7 pi over 6 equals 1/2 x, because you can write it either way, with your 1/2 x in the front or in the back. You can write it vertical like this, or at a diagonal like that. It's not picky about the way you write these. Okay, so now we need to solve for x. So what's happening is 1/2 is being multiplied by x. We need to divide by 1/2, which is the same thing as multiplying by the reciprocal. So this is going to cancel out, and you're going to have x equals, this is going to become 3 and 1. So pi over 3 Let's multiply this by 2 over 1. This is going to cancel out. 2 over 1, that becomes 1. That's 3. So this is 7 pi over 3 equals x. So now we have these two answers. Again, we don't have pi in our domain up here. We always have to verify our answers against the domain, okay? So our domain is -9 to +9 is all that x is able to be. So let's plug in 3 for our possible, our estimate for pi. So 3 over 3 is equal to 1. Does that fit in our domain? Is 1 in between -9 and +9? It is. So that is one of our answers. Okay, now let's look at this one. Let's estimate 7 times 3 divided by 3. It should be 7, and it is. So it's an estimate of 7 times 3 divided by 3 equals 7. And is that between -9 and +9? It is. Well, since we got both of these within the domain, we now need to look at adding 2 pi and subtracting 2 pi to some of these answers, because we still have a wider range, right? This first answer that we looked at when we found the estimate, it was only 1. That's so far away from -9 and +9. I bet we can find more things by adding or subtracting a 2 pi to this one. And this one, it's got a 7, which is kind of close to the 9, but not too close. So we might even be able to find something by adding 2 pi to one of to this original angle, the reference angle, to find some coterminal angles. And we definitely will be able to find some stuff, I think, by subtracting 2 pi, subtracting the time around the circle. Okay, so you have to go until you get something that's outside of the range, because it tells us we need to look it up for all values between -9 and +9. So yes, these are correct, but there's going to be more correct answers because we need all values. And remember, what we found is the tangent of an angle is our 1/3 or radical 3 over 3, 1 over radical 3 or radical 3 over 3. So what we're going to add and subtract the time around the unit circle, or 2 pi from, are going to be our angles here, okay? Not our x values, but what are our angles that we found to be the answer to what angle fits in here. The tangent of what angle makes 1 over radical 3. Okay, so let's start off by our first one. Let's just work with, for now, pi over 6. Let me clear up some space over here. I forgot this was going to need a lot of space. So I should have made it so I could delete my circle when I was done, but I did not. All right, so we've got, we're going to work with the first one, which was pi over 6. And let's go ahead and subtract 2 pi. And let's go ahead and do pi over 6. And let's add 2 pi. So we've got one bigger and one smaller than what we've already found. We already found pi over 6, and that worked for us, right? X became pi over 3. So now we're going to see if either of these two work. And so when we subtract 2 pi, if we're subtracting with a fraction, we have to turn 2 pi into a fraction. We do that by putting it over 1. And then when you subtract, you need to get a common denominator. So this is going to end up being 6, and this is going to end up being 12. Okay, so pi minus 12 pi is 11 pi over 6. Okay, and then remember, just like we did here, we're going to take our angle and set it equal to what we have with x, which is 1/2 x. So equals 1/2 x. Okay, now we're going to solve for x, because that's ultimately what we are looking for. We're looking for the unknown in this very first problem. Okay, so undoing what's being done to x, we're going to multiply by its reciprocal, which is the same thing as dividing. Okay, so this will cancel out, leaving us with simply x. And on this side, our 2 becomes 1, our 6 becomes 3, and we have 11 pi over 3 equals x. Now, we need to see if that fits within our domain or not. So let's do, let's estimate 11 times 3. We're going to estimate 3 for pi, and then divide all of that by 3. What do we get? Well, 33 divided by 3 is just going to be 11. Is that within our domain of -9 to +9? It is not. So this is not a possible solution. So subtracting down is not going to be a possible solution for us. Let's look at if we add 2 pi to pi over 6. Okay, pi over 6 plus 2 pi. Remember, we're going to have to change this to a fraction and get a common denominator. And you're going to end up with 13 pi over 6. Then we're going to set it equal to what our x is being used as, which is 1/2 x, or unknown value is being used here in our tangent. And to undo that, we're going to multiply by the reciprocal. 1, 3, cancel, cancel. X equals 13 pi over 3. So estimate that to be 13 times 3 divided by 3 is going to be 13. And that is bigger than 9. So that is also outside of our domain. So the only value that works, the only x value that we can find with our reference angle of pi over 6 is going to be x equals pi over 3. This is the only one that we got for this. When we subtracted 2 pi, it was too low outside of the domain. When we added 2 pi, it was too high outside of the domain. Okay, so now I'm going to pick a different color just to keep it separate. And we're going to look at the second angle. We're going to find some coterminal angles for that one as well. So we've got 7 pi over 6, and we're going to subtract 1 time around the unit circle, right? So that's 2 pi. Subtracting 2 pi, change it to a fraction, get a common denominator, and 7 minus 12, I think it's 5, 7, 8, 9, 10, 11, 12, yep. -5 pi over 6. And again, we're going to set it equal to 1/2 pi. I'm sorry, 1/2 x. We need to undo what's being done to x, so we're going to multiply by the reciprocal. These cancel out. 2 becomes 1, 6 becomes 3. 1 times -5 pi is going to be -5 pi over 3 equals x. Now, let's see what that is when we throw a 3 in to estimate for pi. So we've got -5 times 3 divided by 3 is going to be -5. Does that fit between -9 and +9? It does. So we have a third answer here. So since we have another answer and it's -5, we need to subtract another 2 pi because it's possible we could still find another answer. Because this came down to -5, we still have a ways to go before we get to our limit of -9. So let's subtract another 2 pi. So how do we do that? We're going to start with our original reference angle of 7 pi over 6. And if we subtracted 1 time around the circle, which was 2 pi, this time we want to subtract 2 times around the circle, which in this case is going to be 4 pi. Okay, change that to a fraction, get a common denominator. Oops. 24 pi. So 4 minus 7, 17. So we've got -17 pi over 6. And again, we're going to set it equal to this right here, 1/2 x. And solve for x by multiplying by the reciprocal. 1, 3. So we've got -17 pi over 3 is equal to x. Those canceled out. And let's see what we can get an estimate to see if it fits in our domain. So negative 17 times 3 divided by 3 is going to estimate out to negative 17. Is that within our range? No, it's much bigger than our negative 9 that we're looking at here. So this one did not work. Now, all we've done so far is go down from that original reference angle of 7 pi 6. We subtracted 1 time around the unit circle, and we subtracted 2 times around the unit circle. So now we need to go bigger until we can't go, till we find something that doesn't fit in the domain. So we're going to have to go bigger with this angle as well. I'm going to erase this green stuff over here so I have some room. So when we go bigger, we do that by adding the 2 pi, or 1 time around the circle, 2 times around the circle, 3 times around the circle, right? So we're going to start with our same reference angle of 7 pi over 6, and we're going to add 2 pi. 7 plus 12 is going to be 19 pi over 6. We're going to set it equal to what's inside our parentheses, which is 1/2 x multiplied by the reciprocal. Oops, that's going to cancel out. 2 becomes 1, 6 becomes 3. So we've got 19 pi over 3 is equal to x. But we don't know if that's an acceptable answer or not until we know if it fits within our domain that we were given, the negative 9 to positive 9. So we have to find an estimate. So 19 times an estimate of 3 for pi divided by 3 is going to end up being 19, which is too big and not in the range, I'm sorry, the domain that we have been given, our values that x has to be between. So our final answer for x is going to be pi over 3, 7 pi over 3, and negative 5 pi over 3. Now these are supposed to be written officially or technically in the order of least to greatest. So I should put the negative 5 pi over 3 at the beginning if you want to get technical and exactly precise. But if you're doing your math on a computer program or having to input answers into the computer, they generally won't consider order important. But it's good for you to know that it should be ordered as x equals negative 5 pi over 3, pi over 3, and 7 pi over 3. So that's what it should be ordered as. All right, so that is going to be pretty much as hard as they get, just because you have to add time trips around the unit circle, whether it's 1 trip around or 2 trips around, forwards or backwards. So in other words, you need to add or subtract 2 pi, series of 2 pi's. Now, this is taken directly from your worksheet. One thing that we have here on the worksheet is at the beginning of the worksheet, it gave us the domain. It said we need to solve for theta to be between 0 and 2 pi. So we need theta to be between 0 and 2 pi, and they used theta here instead of x. Like I said, doesn't matter what we show for the variable. We know that we're going to solve for the variable or the unknown. Okay, so let's get this down to just the trigonometric function here. So in order to do that, we have to undo these things. We're going to subtract 5 from both sides. We're going to be left with tangent of theta, or if you want, you don't even have to have theta written down. You can go ahead and just change it to x, as long as when you write your answer on the paper, you remember that it's theta equals and not x equals. All right, so tangent of x equals 5 minus 5, which is 0. So we need to find a tangent of 0. Our tangent down here in our chart does not show 0. Remember, our tangent is sine over cosine. So we're looking for anything where our sine is going to be 0. A tangent where the cosine is 0 is going to be undefined. Okay, so a tangent where our sine is 0, and I see it right here and right here. So our two reference angles are going to be 0 radians and pi radians. Okay, so that's it. This one was easy. Our final answer is theta equals 0, comma pi. After that last one, I felt like I was doing something wrong because it was so short and easy. All right, let's look at this one. We are still using, for every one of these I pulled from the worksheet, we're going to use the same domain of theta needs to be between greater than or equal to 0, but less than 2 pi. So one trip around the unit circle for theta. So here we have theta, sine of theta. So we need to undo what's being done to our trigonometric function. So we need to divide by -3. So we're going to end up with 2 radical 3 divided by -3 is going to equal sine of theta. Now, I can tell because I have a radical in the numerator that has the same number as a number in the denominator, that this has been rationalized. So I'm going to go over here and let you know that 2 radical 3 is what this would be if it were not rationalized. And we can verify that by rationalizing the denominator just to make sure. So that's 2 radical 3 over 3, and that's what we have here. Except this one's negative, so we need to be sure to carry down our negative. 2 radical 3 equals sine of x or theta. I'm going to keep it as theta this time. So now let's look at our sine values and look at, well, 2 over radical 3. Is 2 over radical 3 an answer here? 2 over radical 3 is not anywhere in our chart, and it's nowhere on our unit circle. And you can remember that because when 2 and 3 is going to be in a 30, 60, 90 triangle. Okay, so you're going to have 30, 60, 90. Remember, our 30 is 1, we've got 2, and we've got radical 3. So when you think of sine is going to be saw katoa, so saw opposite over hypotenuse. Hypotenuse is always on the bottom, so no matter which is opposite, whether it was 1 or radical 3, hypotenuse is on the bottom of 2. Our hypotenuse we have here on the top. So you're never going to have a sine with a hypotenuse on the top. Okay, you'd have something like secant or cosine with a hypotenuse on the top. So you know that this is going to have no solution. And when you look over here at your unit circle, you also don't see anything with 2 on the top or 2 radical 3. All right, so number 6. This one is a little bit more complicated just because our answer over here has a fraction. So there's a couple of ways we can do this. We can start by undoing PEMDAS if we want to. Which would be to subtract 5 from both sides. And then you'd have to subtract 5 as a fraction over here. But one thing we can do prior to that, if we don't want to subtract 5 with fractions, is we can get rid of the denominator. And how we do that is we're going to multiply each term by 5, because 5 is the greatest common, it's the largest denominator here. So if we multiply by 5, we're going to be able to get rid of our 5s as our denominator, okay? But every term needs to be multiplied by 5, okay? Not just one term. So this first term is 5 times 5 becomes 25. Our second term, 5 times 2 over 5, our denominator and our multiplication is going to cancel out. We're going to be left with -2 times sine of theta. This is one term. Terms are separated by addition and subtraction or equal signs, okay? So we already took care of that whole term. Equals, and again, this 5 times the 5 on the bottom is going to cancel out, and we're going to get 25 minus radical 2. Okay? And then we can get rid of the 25 on both sides. if we subtract 25 from both sides, then we're left with -2 sine of theta equals negative radical 2. Okay. So now sine is still not quite by itself. It's being multiplied by -2. We have to divide by -2. This will cancel out. We've got sine of theta equals 2 negatives, make a positive in math. So radical 2 over 2. Now, you should be very familiar or begin to get very familiar with these. When you see them, sine of radical 2 over 2, I happen to know is going to be a 45 right here. Radical 2 over 2. 45. When you look over here, radical 2 over 2 is not listed. Why is that? Well, because it has been rationalized. Remember, it's been rationalized. So 1 over radical 2 is not an answer anyone can give because you're not allowed to have a radical in the denominator. So you would have to multiply by 1, which is radical 2 over radical 2. Okay, so 1 times radical 2 is radical 2, and 2 times 2 is 2. Okay, so that's our radical 2 over 2. So you can see that we've got, for 45 degrees, 1 over radical 2, which is the same thing as radical 2 over 2. Same problem, just made larger by multiplying by, well, not even larger. It's just written differently because we multiplied it by 1 that looks like radical 2 over 2. All right, so I know that it's going to be 45 degrees, and I know that it's going to be positive. So all my signs that are positive, got sine here and here that are positive. So my angles are going to be this one and this one. So theta, we're looking for between 0 and 2 pi. That means I know these are off the list because there's nothing in quadrant 3 or 4 that's usable to me because signs are negative in those quadrants. So theta is going to equal pi over 4 and 3 pi over 4. Okay. And that fits within our 0 and our 2 pi. All right, number 11. Let's see. Now, this one's a little different than the ones we've looked at in the past because it has this, what I call an inside change. It's happening inside some parentheses, even though they may not be written on your worksheet, they're happening, okay? Because this -4 is being multiplied by theta before the sine function is happening to it. So this is happening first. So if stuff is happening first, when we go to undo this problem algebraically, that means we have to undo it last. So we have to undo sine before we get to 4 pi. So we need to remember that we're going to eventually, not 4 pi, 4 theta. We're going to put 4 theta equals whatever we find for our reference angles and then solve for theta. Okay. So let's go ahead and start by undoing any addition or subtraction. We have a 4 here that's being added. So we're going to subtract 4 from both sides. And we're going to get -4 sine -4 theta equals -8. Then it's being multiplied here. So we're going to divide by -4. And you're going to have sine of 4 theta equals 2 negatives, make a positive. 8 over 4 is going to be 2. So sine of 4 theta equals 2. So now we need to find, is there anything on here? Is there sine of anything, any angle that would give us an answer of just 2, which would be a fraction, 2 over 1 or anything like that. But remember, 2 is our hypotenuse, and sine, you never have 2 on the top. So it would be, if you see a 2, it would generally speaking be a 30 or a 60 degree that you'd see it in. And you don't see that here at all. 2's are always on the bottom, and 30 and 60. There's nothing on the top. There's no 2's on the top unless it's a radical 2. But there's no straight 2's on the top. So this one has no answer. Now, let's look at number 12. All right, so that is in parentheses. We know that eventually we're going to have theta over 3 equals whatever our reference angles are, so we can solve for theta. But right now we're just going to leave that in parentheses and undo what's being done to our trig function of sine. So the first thing to undo is this 3. We can subtract 3 from both sides. So 6 minus 3 is 3. That cancels out. That's going to equal -6 sine theta over 3. Sine is being multiplied by -6. So now we can divide both sides by -6. 3 divided by -6 is -1/2 equals sine of theta over 3. Now, sines 1/2. We have sine being 1/2 right here. We see that sine is negative, so I know I'm going to have to look at these two quadrants for a 30-degree angle. 30 is the first one from the horizontal, so it should be here and here. Let's look at our sine, which we know is the second value in our ordered pair, -1/2 and -1/2. All right, so we found both of them that are on our original angles, our original one time around this circle. Okay, so we found that our two reference angles are going to be, let's start with the first one of 7 pi over 6 and 11 pi over 6. Okay, now that is not our final answer, because remember we have, it is the sine of theta over 3 that gave us -1/2. So it's the sine of 11 pi over 6 that gives us -1/2. So this theta over 3 is going to equal 11 pi over 6 or equal 7 pi over 6. So let's go ahead and do both of those over here. We've got theta over 3 equals 7 pi over 6, and theta over 3 equals 11 pi over 6. And we're going to solve for theta. Theta is being divided by 3, so we're just going to multiply both sides by 3. This will cancel out. Theta is going to equal, what's 7 times 3? 21. Let me make sure. Always use your calculator for even simple math, just because you want to get your answer right. So 21 pi over 6. Now this one, again, we're going to do the same thing. We're just going to multiply both sides by 3. This one, 33, 11 times 3, 33. So 33 pi over 6. Actually, let's go back. I didn't simplify these. I'm going to simplify some of these before I write the answers. We're going to go back to this last one because I'm realizing I didn't simplify it. Remember, this is the same thing as 3 over 1 if we turn it into a fraction. So we can go ahead and cancel this to 1 and bring this down to 2. So it's just going to be 7 pi over 2. Okay, and same with this one. That 3 can cancel out. 3 divided by 3 is 1. 6 divided by 3 is 2. So our theta here would equal 11 pi over 2. Okay, hopefully you can see how I reduced those. So we've got these two numbers, 11 pi over 2 and 7 pi over 2. We need to see if they fit within our domain of, so our theta needs to be greater than or equal to 0, but less than 2 pi. All right, well, 7 pi over 2. For me, the easiest way is going to be to just go ahead and plug in 3 for any time I see pi. Just makes it easier for me. So 2 times 3 is 6. So we want to look for something between 0 and 6. 7 times 3 divided by 2. So 21 divided by 2 is going to be 10.5. So our estimate is 10.5. Is that within the range of 0 and 6? It is not. So that is not a viable option. Now, 11 pi over 2, 11 times 2, let's estimate pi is 3, so 33 divided by 2 is going to be 16.5 for our estimate, 16.5. And that is also not within our range of 0 to an estimate of 6. So neither of these can be answers. So we don't even have to add or subtract 2 pi time around the unit circle because our original reference angles didn't even fit within our domain. So we don't need to expand our possible answers if our original reference angles do not fit. So this has no solution because we were restricted to a domain of 0 and 2 pi. Okay, if our domain was larger, these answers could have worked, but we had to make sure they fit between the domain that we were restricted by. And since these did not fit in our restriction, we have no solution. All right, this is going to be our last one for the night. Now, this one I know is going to take up a lot of room. So I'm going to try my best to make it small. So let's go ahead and undo this to get our trigonometric function by itself. And remember, our 0 over 2 is, sorry, not 0 over 2, theta over 2 is going to be equal to whatever our reference angles are. That's how we're going to find our theta later on. But for now, we're going to add 1 to both sides. Add 1, add 1. Okay, this is going to cancel out. -4 plus 1 is -3 equals 3 tangent theta over 2. And we're going to divide both sides by 3. Okay, that'll cancel out. So this is going to be -1 equals tangent theta over 2. Now, I'm going to rewrite this up here just so I can have more room. Tangent theta over 2. Okay, so we want to find out when we are looking at tangents, what tangent of what angle is going to give us -1. Okay, well, we can see right here, we've got tangent of 45 gives us 1. So we know it's going to end up being a 45-degree angle in what quadrant? Well, it's -1. Where is our tangent negative? Our tangent is negative in quadrant 2 and quadrant 3. Our 45-degree angles in those quadrants are going to be 3 pi over 4 and 7 pi over 4. Okay, now we know we're looking for -1, and tangent is going to be sine over cosine. So sine in this case is radical 2 over 2, and that's going to be over negative radical 2 over 2, or cosine in this case. Okay, so since the numbers are the same, only one of them is negative, that's going to equal to -1. So we've checked this out, it works. So even though you didn't see it on the unit circle, tangent you don't see on the unit circle, you have to figure out sine over cosine sometimes, right? So we can see these are again the same numbers, one of them is negative, and so I know that that checks out as well. So my 2 reference angles that I'm going to start with, my reference angles are going to be 3 pi over 4 and 7 pi over 4. Okay, so I'm going to start off with those, and I'm going to put theta over 2 equals. Now let me go ahead and change colors for one of these. This one is what, 7 pi over 4. That way we can see the work that we've done for each one. So let's just look at the blue angle here for a moment. So we've got theta over 2 is going to equal 3 pi over 4, and we need to solve for theta. Okay, so that means we're going to multiply by 2 on both sides. And theta is going to equal 3 pi over 4. Okay, does that fit within our range? 3 pi over 4. Oh, this isn't the one that, I guess I didn't put number 16 in here. I was thinking 16 is the one with lots and lots of answers. I was thinking that's what this is. This one, we're almost done. All right, so 3 pi over 4. Let's estimate for pi by using 3. So let's say our estimate is 3 times 3 divided by 4, or 9 divided by 4. 9 divided by 4 is going to be 2.25. 2.25 is our estimate. And remember, 2 pi, if we take 2 times an estimate of 3 for pi, that's going to give us 6. So it's 2.25 between 0 and 2 pi. It is. And therefore, our 3 pi over 2, I'm sorry, 3 pi over 4 should be an answer. Let me look at what I'm doing here. 3 pi over 4, pi over 2. Oh, I wrote 4 wrong. Remember, I reduced my 4 to 2, so it shouldn't be 4, it should be over 2. Got to pay attention to details. So that means, let's look at this again. 3 pi over 2. 3 times 3 is 9 divided by 2 should be equal to 3 times 3 is 9 divided by 2 is 4.5. 4.5, is that within our range of 0 and 6? It is, so that one works out. So let's look at 7 pi over 4. Remember, we're going to set it equal to our pi over 2. Oops, I thought I had orange. I said pi over 2, I meant theta over 2. So theta over 2 is equal to our 7 pi over 4. And then we're going to solve for theta by multiplying by 2 on both sides. These will cancel out, giving us just theta. And on this side, our 2 will reduce down to 1, our 4 will reduce down to 2, and we're left with 7 pi over 2. That time I wrote the right number in the denominator, so that's good. All right, so let's look up some estimates. 7 times 3 divided by 2. 7 times 3 is going to be 21, divided by 2 is 10.5. Does that fit within our domain here, 0 and 2 pi? It does not. Now, you might hear me say range, because I think that that is a typical term for us to say when we're given a range of values. So range is a proper English term, but it's not the proper mathematical term. This is our domain that we're looking at, because it's going to be our answers that we get, okay? So 10.5, it's not within that domain there. So 10.5 is bigger than 6, so this one does not work. So our only answer is going to be 3 pi over 2. Let me see if I have 16 in here. I don't see that I copied number 16. I did want to go over 16 with you because it had so many values. Let me see if I can just write it out instead of 20 here. We're going to have number 16. 16 is -6 equals -4 minus 2 tangent 4 theta. Okay, so let's undo some of this real quick. We're going to add 4 to both sides. That's going to give us a -2 equals -2 tangent of 4 theta. Dividing by -2 on both sides, we're going to have 1 equals tangent 4 theta. Okay, so now we need to find the tangent of what angle, because we're down to our trigonometric function here. Tangent of what angle is going to give us a 1? Well, we can see here that that's going to be a reference angle of 45 degrees, or pi over 4. And we're looking for positive tangent. So we have a positive tangent in quadrant 1 and quadrant 3. And the 45-degree one is going to be pi over 4, or 5 pi over 4. And you can verify that by putting your sine over your cosine and just double checking. So our two angles that we have, pi over 4, and then I'm going to change colors here, pi over 4 and 5 pi over 4. So let's look at the first angle here. And remember, we have to set it equal to what we have here. What tangent is being taken out, what's happening to theta. We've undone the tangent, and now we have to undo the 4 theta. Okay, so 4 theta is going to equal pi over 4. Now to undo this, because theta is being multiplied by 4, we're going to divide by 4, which is the same thing as multiplying by the reciprocal, or 1/4, multiplying by 1/4. Okay, this is going to cancel out, and our theta will end up equaling pi over 16. Is that within our range? Let's see, 3 divided by 16, because we're going to estimate 3 in place of pi, comes to 0.1875, and that is between 0 and 2 pi. So that will be one of our answers. Okay, now since it was one of our answers and it was a correct answer, now we need to add and we need to subtract one time around the unit circle from our reference angle of pi over 4 to see if there's any more theta answers that we have. Okay, so we're going to do pi over 4 subtracting 2 pi, and we're going to do pi over 4 adding 2 pi. Okay, so we went backwards one time around the circle, and we went forwards one time around the circle. All right, so to subtract this, we have to turn it into a fraction and get a common denominator. So we're going to be left with 7 pi over 4. And remember, this is when we're going to now set it equal to 4 theta and solve for theta. So we're going to multiply by the reciprocal. And we're going to have 7 pi over 16 equals theta. So 7 times 3 is 21 divided by 16. Our estimate is 1.3125. Is that within our range of between 0 and 2 pi? It is. So 7 pi over 16 will be one of our answers. All right, let's keep looking. We also have, we're going to add 2 pi here. So in order to do that, we're going to we subtracted 2 pi. So this is -7. Subtracting pi minus 8 is -7 pi. -7 pi, negative. Okay. Is that within our range? It is not. So this is a negative number. So I hope that if you're following along, you caught that. When we subtract 2 pi, it's pi minus 8 pi, which gives us -7 pi. So we know that that did not work out. I have a circle around it. Let me erase that because it did not work out. It was not within our range. So because 0 is in our range, we know we don't have to go any further. I said range again, domain. We don't have to go any further than this because we got to a point that's outside of our domain that we have. So we don't have to continue subtracting 2 pi from this. Okay, so now over to adding 2 pi to our reference angle here, 2 pi. So we've got it as a fraction. Let's change it to a common denominator. So let me do this one correctly. Pi plus 8 pi is going to be 9 pi over 4. Set it equal to our 4 theta and solve for theta. And we're going to have 9 pi over 16 equals theta. So let's find what the estimate is. 9 times 3 divided by 16 is 1.6875. 1.6875. And that is between our 0 and our 2 pi. So this is one of the possible answers, 9 pi over 16. Okay, so far we have 2 possible answers. Since we added 2 pi and we still were within, well within, because remember this is 6, well within that domain, our restrictions that we have, we're going to add another 2 pi to this. So we're going to pi over 4 is our original reference angle. We already added 2 pi. So now this time we're going to add 4 pi. So that's 2 sets of 2 pi, right? 4 pi is 2 sets of 2 pi. And I'm going to put it over 1, and then I'm going to change this to a common denominator. And so pi plus 16 pi is going to be 17 pi over 16. Set it equal to 4 theta and solve for theta. So multiply by 1/4. This is going to cancel out, and we're going to have 17 pi okay, I see what I did here. I put 17 pi over 16. I was jumping the gun here. It's 17 pi over 4. When you add, you have a common denominator. 4 and 4 stays 4. So pi plus 16 pi is 17 pi over the common denominator of 4. 17 pi over, now when you multiply 4 times 4, you're going to multiply the denominator to get 16. All right. When you have these problems that have all of these little things where you have to add and subtract and find all the additional things, you're going to come into a lot of fractions. And so you do need to pay attention and double check your answers as you go. If something doesn't feel right, if it doesn't sit right, if you're going through it and you're like, that just doesn't seem right to me, go back and double check. Use your calculator and look at the work that you've done to see if you do any of these simple errors that people do. Just, it's so common. These are common errors. And so you do need to pay attention to the details. Don't rush, and always double check and make sure what you have makes sense. If you notice, all of our final answers are going to be over 16. Okay, even when they don't fit within our domain here, our final answer is going to be over 16. So if you have something that doesn't fit that same pattern, say, hey, that's sticking out, that's something odd, and go back and try to figure out what happened to cause that issue. Okay, all right, so our final answer was 17 pi over 16 equals theta, and let's see if that fits within our range. 17 times, we're going to estimate 3 for pi is 51, divided by 16 is 3.1875, and that is between our 0 and our 6. So this is also a possible answer. Okay, so what does that mean? Well, we have to take one more trip around the unit circle. So we're going to add one more time. If last time we had pi over 4 plus 4 pi, this time we're going to have pi over 4 plus 6 pi. Because one time around the unit circle is 2 pi. So we're going to increase by 2 pi every time we want to take another trip around the unit circle. Change that to a fraction and get a common denominator. Okay, so pi plus 24 pi is 25 pi over a common denominator of 4. Set that equal to 4 theta and solve for theta by multiplying by its reciprocal. So here is going to cancel out, and 1 times 25 pi is 25 pi over 4 times 4 is 16. And that is going to be our theta. Now let's estimate. Let's stick 3 in for the pi, 25 times 3 and divide by 16. And we got an estimate of 4.6875. Does that fit within our range of 0 and 6? It absolutely does. So we found another answer. So we are not done yet. We haven't gotten outside of our limits yet. So we need to still keep going. Okay, I'm going to just draw a line over here so we can separate our work. So we added 6 pi last time. So let's take our same reference angle, pi over 4. And this time we're going to be adding another 2 pi. So instead of 6 pi, it's going to be 8 pi over 1. Change that to a 4. 32. And pi plus 32 pi is 33 pi over a common denominator of 4. Set it equal to 4 theta and solve for theta. Multiplying by the reciprocal. Cancels out. 1 times 33 pi is 33 pi over 4 times 4 is 16. So that's what we have as theta. Now let's estimate. 33 times 3 should be 99 divided by 16. 6.1875. 6.1875. Oh, that's so close, but it is outside of our estimate that we have for our domain. But it is so close. I really would like to get an exact answer. So you should have in your calculator where you can plug in 2 pi and hit enter. 2 pi. And I got for 2 pi, I got 6.2831, etc. So I think 4 decimal points are going to be enough. Now, if I do the same problem, 33 times pi divided by 16, I get 33 pi divided by 16, I get 6.4795. So which one is bigger? This one is bigger. So it is outside our domain. And we kind of saw that with our, hold on, I'm sorry, my computer's deciding to do something funky here. We saw that with our estimate, but there it goes. Okay, you can see with our estimate, but I wanted us to be sure. So, well, now that we've verified by actually putting in pi into our calculator and seeing that 33 pi over 16 is bigger than 2 pi, we already know that for sure it is. Another way you could have done that is just 33 divided by 16 and seeing that that is 2.0625, which is bigger than the 2 before the pi. Okay, so we've already found the lowest possible answer. Remember, because then for our reference angle pi over 4, we found when we subtracted 2 pi, this was outside of the range, the domain that they gave us. And when we added 2 pi all the way up to 8 pi, we finally found the one that was outside of our domain. So we have 1, 2, 3, 4 possible answers for this one reference angle. So there was a lot there. Now we need to do the same thing with this blue angle that we have here, 5 pi over 4. So I'm going to do 5 pi over 4 equals 4 theta. Remember, we're going to multiply that by its reciprocal of 1 over 4. This is going to cancel out, and you're going to have 5 pi over 16 equals theta. So 5 times 3 divided by 16 is going to be an estimate of 0.9375. That fits within our range, our domain up here. So that is a possible answer. Now we're going to do the same thing, 5 pi over 4, and we're going to subtract 2 pi because we want to find our lower limit. We want to find the answer that goes outside of that limit so we know where to stop. Put this over 1, get a common denominator. Okay, 5 minus 8. This is going to be negative 3 pi over common denominator of 4, set it equal to 4 theta, and solve for theta by multiplying by the reciprocal. So negative 3 pi over 16. I don't even need to find the estimate of this because it's negative. I know that that's smaller than 0. So I already know that that's not going to work. Okay. So we've already found our lowest answer possible. Now let's go the other direction and start adding 5 pi over 4 plus 2 pi. And we're going to put that over 1. Common denominators. Common denominator 4. This is 8. 5 plus 8. 13 pi over common denominator of 4 equals 4 theta. Remember, we got our 4 theta from right here. The tangent of what angle equaled 1, and we said the angle of 5 pi over 4. So we're setting that equal to 4 pi for every single one we're trying, and then solving for theta. So don't forget where we got that from. Multiply by the reciprocal. This is going to cancel out. So we've got 13 pi over 16. This is going to be our theta. Let's estimate that 13 times 3 divided by 16 is 2.437, an estimate of 2.437, and that fits within our given limits. So let's do this again. 5 pi over 4 plus 4 pi. 1, 4, 8, 5, 8, 9. It's not 8 pi. Let's pay attention to details here. It's acting as if that was 2 pi. It should be 32. All right. No, I'm sorry, 16. I don't know what I'm doing for math here. When you get a common denominator, we multiplied the bottom by 4, so we're going to multiply the top by 4. And 4 times 4 is going to be 16. So this is 16 pi over the common denominator of 4, which equals 4 theta 16. So multiply by the reciprocal of 1 over 4, 1 over 4. And you've got 16 pi over 16. Oh, you can tell it's getting late for me. I do mess up more the longer I've been going. So I want to look at this. I hope you see what I did wrong. I hope you're sitting at the computer yelling at me going, oh my gosh, Miss Andrea, look at that. All I did was write 16 pi down here. I didn't add the 5 pi to it, okay? So we're going to start all over right here. 5 pi plus 16 pi is going to be what? 21 pi over our common denominator of 4. And we've got to set that equal to 4 theta. Okay, now we're going to multiply by the reciprocal. And this will cancel out. And you're going to have 21 pi over 16. That looks much better. Now, 21 pi over 16. Go ahead and do the math. 21 times 3 divided by 16 is going to be an estimate. This is equal to theta, and our estimate is going to be 3.9375. And that's well within our limits. So that's another possible answer. So last time we added 4 pi. Let's see if I can do a better job adding the next time around the circle. So if we added 4 pi last time, let's add 6 pi this time. So 5 plus 24, Miss Andrea, is going to be 48 pi over 4. pi over 4. And that can be reduced. 28 plus, let's see, 24 plus 5 is 29. I don't know how I got 48. What is going on? Always use your calculator. 5 pi plus 24 pi is 29 pi over 4. Okay, 29 pi over 4, set it equal to our 4 theta, which again we got from up here, 4 theta. Now we're going to solve for theta times 1 over 4 times 1 over 4. These are going to cancel out, and we're going to have 29 pi. 1 times 29 pi is 29 pi over 4 times 4 is 16. Is going to be equal to theta. And let's see if that works for us. 29 times 3 as an estimate for pi is 87 divided by 16 is going to be an estimate of 5.4375. Does that fit between 0 and 2 pi of our limits? It does. So that is another possible solution. Okay. So we have not found our limit yet. Let's add one more. Hopefully this will be our last one. 5 pi over 4 plus last time was 6 pi. This time we're going to add 8 pi, turn it into a fraction, get a common denominator. Okay, 5 plus 32 is going to be 37 pi. Over a common denominator of 4, set it equal to our 4 theta from up above, 4 theta, and solve for theta. It's going to end up 1 times 37 pi, so you're going to have 37 pi over 4 times 4 is 16. So 37 times 3 is 111 divided by 16. It's going to be 6.9375, 6.9375. So this is definitely outside of our range of 0 to 2 pi, which estimates to plain old 6. So 6.9375 is much larger. And we finally found time around how many times around the circle it took to get outside of the limits that were imposed upon us. So each one of these is a possible answer. So you would order it, if you wanted to be technical, in the order from least to greatest, but you put theta equals, I'm just going to put them in the order that I got the answers. So that was this one. Our next one is 9 pi over 16. That's this one. Our next one is going to be 17 pi over 16. If you notice, they're all over 16. The next one is 25 pi over 16. And then you're going to keep going. I ran out of room and close it. So make sure you do all of those. And you can see we have a total of 1, 2, 3, 4, 5, 6, 7, 8 answers. And hopefully that helps you. All right, I'll see you tomorrow.